I'd like to start by talking about the meaning of pH. I believe you all have heard of pH, but you have not been taught what the mathematical meaning of it is. So as you know, pH refers to how acidic a solution is, but there is a mathematical meaning behind pH. The H in pH stands for H plus ions, and this would be concentration in molarity. So that would be moles per liter. That should make sense to you because H plus ions come from the dissociation from acids. So the pH will tell you how acidic something is by telling you how much hydrogen ions there are in the solution. Only the dissociated hydrogen ions count when calculating the pH values. If it's not dissociating, it's not very acidic because there are less H pluses in solution. And that's the difference between a strong and a weak acid, as you know, how much dissociates. So a strong acid like HCl, the whole solution will be H pluses. Every hydrogen will dissociate. Whereas something with a carboxylic acid, some of the H pluses will remain bound to the molecule, and that makes it a weak acid, less H pluses in solution. If there are many H pluses, or H3O plus also is the same, in solution, then that's acidic. The pH is less than 7, has a high concentration. If there's very little, then it's a basic solution and the pH is greater than 7. And neutral solutions have an equal concentration of H plus, which we know is the acid, and OH minus, which is the base. So equal equals a pH of 7. As you know, water can act as acid or base, and the reason water is neutral is because whenever an H plus dissociates, it leaves behind an OH group, and that makes them equal in concentration, which would be a pH of 7. The mathematical relationship can be shown in this table here. So in this first column, we have the molarity, moles per liter, of H3O plus. It's the same thing as H plus. And then this is the exponential notation of these numbers over here. And then it gives a pH value. And on the last column, we have the OH minus molarity. And so you're looking for a pattern here. Let's look at the pattern. We have a 0.1 molar solution of H plus. As you know, 0.1 exponential is 10 to the minus 1. And the pH of that is 1. And the OH molarity is 10 to the minus 13. And the next one, we have 10 to the minus 2, pH of 2. And our OH concentration is 10 to the minus 12. And so on and so on and so forth. And you can write more of these. This would be like this, and so on and so forth. And you can see that the concentration of H plus is getting exponentially smaller as the pH gets bigger. And as the H plus concentration decreases, you can see over here that the OH minus concentration increases. If we look at the first question, which has a higher concentration of aqueous H plus ion, so H3O plus, same, a solution of 6 or 8, the answer would be 6. pH 6 has a higher concentration than pH of 8, and it's not a small difference. It's the difference of 100 times more concentrated. A pH of 6 is 100 times more concentrated than a pH of 8. And we can see that in the numbers here and the numbers here. So when you're looking at the pH of solutions, one number up doesn't feel like a large difference in pH, but each time you go up, that's a difference of 10 times the concentration. When the pH value changes by 1 unit, how does the H plus concentration change? I just answered that. The H plus concentration changed by a multiplicative factor of 10. 10. So when you're looking at a difference of pH from 1 to 4, that's a huge difference in the concentration of H plus. Scientists wanted a simplified way to talk about the amount of H plus in a solution, and that's how we got the pH scale. Let's look at number 3. The equation below expresses that the mathematical relationship between column 2 and column 3. Try to complete the second equation so it also is mathematically valid. If the H plus concentration is equal to 10 to the negative pH, then the pH is equal to the negative log of the H plus concentration. When you're writing concentration, so molarity, you use brackets. The brackets denote molarity. So those two things mean the same thing. So if I said this H plus. What I'm talking about is the concentration of H plus, and that is in molarity. So this is the equation for pH. And now let's use our log knowledge to figure out what the pH of a 2 times 10 to the fourth solution is. So remember from the last homework you did that the log of something times something equals those two things added together. So if we took the log of 2, we would add that together to the negative log of 10 to the negative 4. So you should be able to easily see that this is 4. And from the homework that you did previously, you should be able to see that the log of 2 is 0.3. Remember, this is negative. So negative 0.3. And if we add those things together, we get 3.7 is the pH.